If you haven't done so yet, please pause the video and reread the problem before listening on. In part A of this question, we are asked how many electrons are needed to form a charge of -2 nanocoulombs. Now, to answer that question, we have to know a fundamental fact about the electron. We need to know that one electron will carry a charge of negative 1.6 times 10 to the -19th coulombs. So that's one important thing that we're going to need to know. But we also need to know how to convert from nanocoulombs into coulombs. Now, it turns out that 1 nano of any unit, so it could be 1 nanocoulomb, 1 nanosecond, 1 nanodollar even, but whatever it might be, 1 nano of that unit is equal to 10 to the -9 of that very same unit. So in the case of nanocoulombs, we could say 1 nanocoulomb is equal to 10 to the -9 coulombs. So with those two facts, what we will do is basically convert the given charge of -2 nanocoulombs into the number of electrons. So we will do that by writing down that given quantity, -2 nanocoulombs. Now you might want to pause the video and look at the two facts stated earlier and see if you might be able to set up a conversion. But the first conversion factor we're going to use is this one right here. We can see that 1 nanocoulomb would be equivalent to 10 to the -9 coulombs. And you'll notice how we have set that up. We've strategically set it up so that the given nanocoulombs and the nanocoulombs that we're putting into our conversion are sort of diagonal from one another. And what that means is that they will cancel dimensionally. So by setting it up diagonally, we can cancel the nanocoulombs. And now our present unit is in coulombs. And we can see from the second conversion that 1 electron carries a charge of -1.6 times 10 to the -19th coulombs. And once again, we've set this up very strategically so that the coulombs and the coulombs in the denominator will cancel out. So those units would cancel out because they're diagonally situated. That's going to leave us with a unit of electrons, which is exactly what we're looking for. So now we want to pick up our calculator, carefully using parentheses, and enter it in. And when you do that, you should get 1.25 times 10 to the power of 10. And again, the unit here is electrons. So this is the correct answer to part A of the question. Let's take a look at what part B is asking us to do. It says in part B, how many electrons must be removed from a neutral object to leave a net charge of 5 microcoulombs? So let's imagine we had some neutral object, maybe it's a metal sphere. And in order to take a neutral metal sphere and convert it into a sphere that has a charge of positive 0.5 microcoulombs, we're going to have to remove electrons from it. We have to remove electrons in order to create a positive charge. So we can imagine that we're removing a certain number of electrons in order to create that positive charge. And if we create a positive 0.5 microcoulombs, that means that the electrons we removed will carry a negative 0.5 microcoulomb charge. So this is essentially the given quantity is negative 0.5 microcoulombs. And now all we have to do is a conversion, just like before. We're going to try to convert this into the number of electrons. Now we talked about nano earlier. It's worth saying that 1 micro of any unit is equal to 10 to the -6th of that said unit. So if you had 1 microcoulomb, you could say that that's 10 to the -6 coulombs. So let's use that conversion factor. You might want to pause the video, see if you can set up the conversion correctly. But hopefully we can see that we would put the 1 microcoulomb in the denominator and the 10 to the -6th coulombs in the numerator, because then the microcoulombs would cancel out. To get from coulombs to electrons, we use the same conversion that we used earlier, in which we said that 1 electron carries a charge of -1.6 times 10 to the -19th coulombs. And setting the conversion up in that fashion allows these coulombs to cancel. So now we'll pick up our calculators and enter this in. Notice that this negative sign and this negative sign down here would end up canceling. When we do this, we get an answer of approximately 3.13 times 10 to the power of 12, and we are left with the unit of electrons. So this is the correct answer to part B of the question.